Welcome to part 2 of 21, chapter 21. What we're going to be talking about here is the elementary charge. The charge is quantized, and we're also going to talk a little bit about the fact that charge is conserved. So, electric charge is quantized. What does that mean? That means it can only have certain values. It's kind of like our money. Our money can only have values that depend on what? The penny, right? You can't have more than a penny or less than a penny. I mean, you can't have less than a penny. Penny is the smallest unit. And above that, you can only have multiples of pennies. So the same is true for charge. You can only have multiples of the electron charge. Now, I'm lying to you a little bit. We will probably cover this at the very end of the semester. It's a small lie, but you can only have multiples of charge. So any charge must be an integer of the electron charge, either plus 1, minus 1, plus 2, minus 2, and so on. And the elementary charge, which we call E, is 1.602 times 10 to the minus 19 coulombs. All right? That is the charge. The negative of that is the charge on the electron. The positive of that is the charge on the proton. Electrons, protons, and neutrons, which are neutral, make up all ordinary matter. There was a great experiment by a guy named Millikan called Millikan's oil drop experiment, where he built a device that would create a very fine mist of charged oil droplets. And he then had and we'll get to voltage and charge later, and he had a little voltage he would apply, and basically he would adjust the voltage until an oil drop came to a stop. And you'd have to look at it with a little microscope attached to the device, see the oil drop come to a stop. And he discovered that the voltages, all of the little oil drops were the same size. That was one of his brilliant little bits he did. He determined that the voltages it took to stop oil drops were quantized. That it couldn't be just any voltage. By the time you got an oil drop to stop, it had to occur in multiples of these little bitty steps. And it had to be 1 step, 2 steps, or 3 steps, which indicated that there was 1 charge, 2 charge, or 3 charges on the oil drop. Great little experiment by Millikan. So, charge is quantized. It comes in units of 1.602 times 10 to the minus 19th coulombs. And that corresponds, the negative version corresponds to electron, positive version corresponds to a proton, neutron is neutral. So when you talk about having charge on something, it has to be some multiple of that. Now the next bit, charge is also conserved. All right, charge is a conserved quantity. And what does that mean? That means if you start off with 10 electron charges, you end up with 10 electron charges no matter what happens in between, right? Or if you start off with 0 total charge, and here's a good example. This is an electron, E minus. This is a positron, E plus. You can actually combine an electron and a positron. When they annihilate, you get 2 photons, all right? So you can have this process going on. What do we have on this side? Then photon is indicated by the gamma. All right. We have 0 charge on this side. All right. 0 charge, 0 charge. We always have 0 charge. Charge is conserved. And below that, a different process. This is a great emulsion photo of this process happening. Photon comes in. Photon comes in from here. Boom. All right, then the photon interacts a little bit with something and splits into an electron and a positron. So an energetic gamma ray comes in and boom, off it goes as an electron and a positron. There's a magnetic field here probably. They curve in different directions with a magnetic field. They also repel each other a little bit, but they're moving so fast. That's not the key issue. The key issue is the magnetic field. And so this is another example of conservation of charge. When you have any chemical reactions, Total charge is conserved. Charges might move around between atoms or molecules, but total charge is always conserved. And the total charge of a neutral atom is 0 because it has an equal number of protons with plus charges and electrons with negative charges. And I believe that gets us to the end. So to review, we have electric charge, we have conductors and insulators, charge is conserved, we have Coulomb's law, all right, F equals 1 over 4 pi epsilon naught, product of the charges, the magnitude of the charges divided r squared, and the elementary charge is 1.602 times 10 to the minus 19th coulombs. And that is it for chapter 21.